focus here on AXI 4 standard, which is one of the AMBA standards as discussed in the lecture. Will be, well, kind of, well, 3 tasks, slash 2 tasks plus a bonus task. One of them is for RISC-V UART peripheral implementation. So basically I design how you can get a UART very simply into your system on chip or onto a system with a soft core. Then understanding AXI IP core design, how that works when you would generate it with Vivado and what you need to do yourself. And then a bonus task related to the task 2. We have here, I will show this later how to get there. But basically, it's the task to create a new Vivado project and create a block design in there. Load your AXI_UART Lite IP cores. You should find it when you type in UART Lite, for example, into the IP core search, and Microplace RISC-V CPU. Well, although it doesn't really matter which CPU you kind of use here. And then run the block automation and connection automation. And then you should get something like this. I on purpose realigned this so that everyone can submit their screenshots of their block diagrams. You of course also can submit your block diagram file or the ticker script or whatever. All these kind of methods work. And what I want to have here is like some screenshot of the block diagram / visualization, so I can look into that everything is connected correctly, and then explain the different design blocks and why they are needed, or even may not be needed. Some of the design blocks you may not need always. The goal is here to have also 2 UART ports, and the goal is that you understand why certain AXI components aren't being added or not. Then we have, so this is basically the example for a very simple design when you have already all the components given, how you can then make your own firmware or your own FPGA design very briefly, and then, for example, write the core for the processor, for the RISC-V processor. And then the second part is, and I'm going to show this in a second, there is a function in the create and package new IP function in the Vivado, which we had used previously. And in there, or that's how I created the previous IP cores, like a UART IP core. And with that function, you can also create very simply an AXI IP core. And then there's 4 questions to this: which block designs, which specification do you use, and then for the understanding is comment on at least each state and condition in the auto-generated code. So we'll show that in a second what there is, and some interpretation what they mean and why they are there. And to make it simple, just submit the VHDL file with the comments in there. And then basically what functionality is missing to make your AXI UART IP core work based on our previous UART designs, which you have created in the previous assignments. So basically so the task is to create a AXI UART IP core ourselves based on the UART design blocks which we used in the previous assignments. And then there's the bonus task where it's where basically the task is what you just did in theory, and you try to understand, also implement the functionalities and the required logic to have a UART AXI IP core, and this would ideally help you also in the future to make an AXI SPI or whatever IP core in the future as well. You can use here any additional tools or websites or whatever, and to get the points, we'll need a simulation result, so a waveform showing that you have provided some simulation input into the UART and from the AXI to the UART, so that you have bidirectional communication. And then just submit the VHDL files and the ticker script or whatever instructions to run the project. And this should allow me then to even give you some amount of points, even if you have some bugs or whatever in your VHDL code left, which of course can happen, and that's the task here to give you an opportunity to implement what you have thought through and get then also points for this. In Vivado, this will, look, I have already created those things, so I have here block designs. Just for the sake of this assignment, very briefly, we can create a new block design as previously said. We can, just loads. Could have also shown a full diagram, but this is much nicer. So you can search in here for UART, for example, and then you see here already you have the UART light, that design block you have, and then you have a CPU or whatever you search for, maybe not CPU, fine. MicroBlaze is the processor called. So you can use whatever you want in here. I've just used the version MicroBlaze V, which is RISC-V version, which got previously released just like a few months ago. And then you have just these blocks, and then you can run a block automation, which will create certain functionalities to it. And then after this, you can also run the connection automation. So that's very easy. From a workflow, what is very difficult, we had this very, very beginning in the course. I showed you this functionality, but now is also, you should have the skills to at least try to understand and to answer questions why certain blocks are being added and what they mean, and if you need them actually or not, or if the design will work or not. And if you would implement. Of course, some of you have also the boards, and you can write test benches to this all, and you can write also the processor code if you really want to dive into that to understand if it works or not. But that's a bit beyond the scope. I should have connected the power cable. There we go. And then we have the run connection automation, which basically just gives me, I can select all of them, and then it will connect also my my AXI interfaces as well. And it will look something like this in the end. And that's what you can go by. So that's task one. And then the other task is with the tools, create and package new IP core. And then you see here, create new AXI peripheral. You click here on next. You will select down here, create new AXI peripheral. And then you can give it whatever name. I will just leave this in default right now. Give it a good name, some version number, something as what it should display at. You may also want to specify the IP location. And then you see already here which specifications you want to use. I will leave this all to you. You can use here whatever stream full, whatever you would like. And that's all up to you. And then I can either just directly add the IP to the repository, but I've not done anything yet. So in this case, I want to edit the IP as well. And this will give me directly access. You can also open this IP core in a second up as well. So let's see if the demonstration effect. Yes, wonderful. So we have here now the interface for the actual IP core design.
For the task, is it necessary to change some parameter in the setup you did?
Depends what IP core you want to do. I've selected the slave because the easiest to understand. Sorry, the AXI Lite slave. And you can add and change the bit width and whatever you want, but they do not really impact how the logic works. The question in this assignment is what logic happens here and how it's being done. And then you can go here into the VHDL code. You see already in here there's just the entity file, so the structure. And then in here is the logic. And the goal is for you to describe each of the logic blocks. So you can, the signals are all described. There's all in the standard. You can look this up online or whatever. I expect those to be understood, and you will not get very far without understanding them. So I do not expect you to write anything about this, but what I expect you to write about is, for example, you have a reset, and then you have a state machine. So you move from each state from idle to W address, and what happens in here, why are these conditions here, and why do I need to trigger those conditions to get into the next state. So you can also map this, of course, to a diagram, which I've shown in a lecture for a timing diagram, how the AXI system actually works. And then you will also, so there's also comments in there that should help you as well. They're auto-generated, so it's all everywhere the same. And then also down here as user logic. But what you need to add as user logic to create or integrate the UART. Consider if you, in your design also, if you need any buffer / FIFO, how that can be implemented, if AXI supports it, or if you need to add a extra logic, or in which way you want to do that. So basically think a bit about how you can do these, how you could create the code. And the bonus task then is to basically implement the design blocks which you have described before or have referred to before, which should then be okay to do because you have understood everything, but it might take some time to write the code and to debug and understand it actually. So that is already everything. So you have here also, of course, here AXI Lite has only 32 or 64 data bandwidth. How would you manage, for example, to integrate the UART 88 bytes into this? There's various approaches to do this. For the tasks here, but to think creatively, how can you do that? It doesn't have to be the most efficient solution. We are in a learning phase, so it's most important that you right now find a solution. Yes, I think that's it. And yes, then you can, and then when you basically, you can, for those who have written the code, they can either submit the code, or just to close this up, you can always just give it a new version number. And when you click through the process, you come here, repackage IP. That will tell you where the IP is, and you can just submit the IP core as a zip file format. For the rest, you're mostly describing things, so it might just be easy for you to just send this VHDL file and write the comments in here. For those who want to implement it, you will have to add additional sources like the UART into this project. So you have to go in here, add design courses or simulation sources and so on. Yeah, that should work. And if you have any questions, especially regarding implementation, you're anywhere stuck, please write an email, write into the forum or anything, because then I can help you to debug it, because the goal is here to teach you or to help you to make the learning as easy as possible, not to make you struggle with any stupid or bugs which come along the way. Good. That's it already.